So we're starting a new chapter. This one is dealing with volume and surface area and area of different figures. So the first section, area of plane figures. I gave you a geometry formulas reference, so use that. I don't have a copy of it on here, but use that to help guide you throughout this chapter. It's really going to be helpful. So first section, really easy. This is stuff you've done before. It is area of plane figures. Plane figures are 2D shapes, so two-dimensional shapes. So up at the top, I've got your formulas. So you can refer back to those while we're doing those. Notice how a couple of them have perimeter with them because we'll talk. There's like maybe one or two that deal with perimeter. So just looking at these shapes, I want you to go through and find the area of each of these plane figures. So the first one is a square. We know that because two sides are congruent, which means these sides are also congruent. And so the formula for the area of a square is S, so the side, where S is the side, squared. So the area equals 8.5 squared. Therefore, the area is 72.25. And then this is where it's important. It's feet squared. Notice how many units here are feet. You need to have the units. Units, when we're talking about area, are always squared. Square units, whatever it is. So in this case, square feet, okay? Think of it as 2D shapes, so it's to the second power, okay? So that's the formula for the area of a square. And that's all you're doing on these problems is you're plugging the values that you're given into these formulas and solving for area. So let's look at... I want to look at number 5 just because when we were looking at trapezoids in the last section, we dealt with non-isosceles and isosceles triangle or trapezoids, where isosceles trapezoids were the ones where the legs were congruent. Okay, but remember, they don't always have to be that way. In this case, this is a non-isosceles trapezoid. Because I have a right angle here, that means these two bases are parallel, making it a trapezoid, okay? So you use the formula for the area of a trapezoid up here, which is one that you don't always see so much of. So the area is going to be equal to 1/2 times the height, 16, times base 1 plus base 2, so 19 plus 27. It doesn't matter which one's base 1 and which one's base 2. Okay? And so when you put that in your calculator, you end up with 368 centimeters squared. And that's it. That's what we're doing here, is we're plugging these values into the formulas up above and on your reference sheet and finding the area. Notice on number 7, this is a triangle. However, my height is not written inside. It's written out here. That's okay. This is still the height of the triangle, not this in here. It's the height of the whole thing. So this is the height of my triangle. Right H there. This is still the base, not this whole thing. So this is the B. Okay? So you plug those into your formula for the area of a triangle. On number 9, notice how up top here we don't have a formula for a half circle. However, hopefully it's a little bit of common sense that the formula for a half circle, that was a terrible circle, for a half circle is equal to 1/2 of the formula for a regular circle. So 1/2 pi r squared. See if I can't draw that a little better. Whatever, good enough. Okay, so that's the area, the formula for the area of a half circle. So if you look at number 4, pay attention to what you're given. Instead of being given the radius, you're given the diameter, so you're given this whole thing. You got to think about, how can I use that to find the radius? Think back to your properties of a circle. Okay, you got to think back to a little bit of 8th grade math. Okay, so if you flip it over, I want to look at number 11. So when our formula for the area of a triangle is 1/2 base times height, right? Okay. In this case, we're not given the height of my triangle. However, we can find that, since this is a right triangle, we can find that using our Pythagorean theorem. So remember, x squared plus 7 squared is going to equal 18.2 squared. Okay? That's going to help you find this side, which happens to be your height. You can use h if you want. Okay? That's going to help you find your height. Same thing with this trapezoid. Sometimes you have to split it into some pieces. So I can split this into 2 right triangles and a rectangle. So this would be 7. Since this is an isosceles trapezoid, that means this base of this little right triangle and the base of this little right triangle are congruent. To find that, I can take 19 minus 7. This gives me 12. And then divide by 2, which is going to give me the bases of both those little triangle pieces. Okay? That's going to allow me to find the height of my trapezoid. Okay? Once you find that height, all you have to do is plug that into your formula for the area of a trapezoid, which remember is 1/2 height times base 1 plus base 2. Okay. 13 through 18 and, 13 through 18 are all word problems. So you're going to have to think about, what can I do here how do I plug this into my formula to find whatever it's asking for. So for instance, on 13, so it gives me the area. So the area equals 45.5 centimeters squared. And it gives me the base, which is 14 centimeters. Okay. Now since I'm dealing with a triangle, I take my formula for the area of a triangle. Because I want to find the height, I just plug these values in to my formula and solve for h. So 45.5 equals 1/2 times 14 times h. Let me put that in parentheses. There we go. Times 14h. Okay. Then I just use my algebra and solve for h. Okay. So that's what these problems are doing. Go through and identify what you're given. Say, okay, I'm given the area. Okay, A equals this. Okay, I'm given the base, so B equals this. And then look at what it's asking you to find. Okay, it wants us to find the height. Okay. I want to look at just 17 and 18. Pay attention to what it's asking you for. Okay. It may not be asking, you may have to go a step further. And then the application problem, I want you to go ahead and try this one. So the dimensions of the deck are shown down here. If 1 can of paint covers 72 square feet, we want to find out how many cans we'll need to purchase to coat it twice for 2 coats of paint. Okay, so we need to find the area of this trapezoid. Okay, so the area equals 1/2 times 16.5 times 24 plus 14. I'm going to put that in my calculator, end up with an area of 313.5 feet squared. Okay, so that's the area of the deck. Okay. Pay attention, however, to what it's asking you, what it's wanting to cover. It's wanting to cover it with 2 coats of paint. So we need 2 of the area of the deck. So we need to take 2 times 13.5, which is going to give us 627 feet squared. So this is the total area that we're trying to cover with the paint. Okay. If 1 can covers 72 square feet, we need to find out how many cans we will need to cover this much area. Okay. So think about how you would do that, how you would figure out how many cans, if you know you need to cover this much area and you know that 1 can covers 72 square feet, think about how you'd find out how many cans you would need. Okay. So go ahead and finish all the problems on here. You'll have to finish 13 and 11 and 12, as well as go ahead and finish the application problem, and then finish the ones on the front, or do the ones on the front. And that's it.